Order, all rise. À l'ordre, veuillez vous lever. This hearing of the Elliot Lake Commission of Inquiry is now in session. Cette audience de la commission d'enquête sur Elliot Lake est maintenant ouverte. Please be seated. Veuillez vous asseoir.
Morning, everybody. Mr. Carr-Harris, you prepared to proceed this morning?
I am, thank you, Your Honor.
Thank you, Mr. Clerk.
Mr. Commissioner, our first witness is Dale Craig, sitting on your right. Mr. Craig is a highly experienced and...
We'll have him sworn in.
Oh, sorry.
Good morning, Mr. Craig. Do you prefer to proceed in English or in French? Right. And do you wish to swear on a religious document, or do you wish to affirm? We have the Bible, the Holy Scriptures, or the Quran?
Bible's fine.
All right. Could please put your hand on the text. Do you swear that the evidence to be given by you to the Commission shall be the truth, the whole truth, and nothing but the truth, so help you God?
I do.
Thank you. And could you also state your name in full and please spell it for the record?
Dale Craig, D-A-L-E-C-R-A-I-G.
Morning, Mr. Craig. I'm sorry I interrupted you, Mr. Carr-Harris. Go ahead, please.
At least we'll get the truth now. Thank you. Good morning, Mr. Craig.
Good morning.
Thank you for being here. Mr. Craig is a highly experienced and highly respected professional engineer that the Commission has retained to assist them in their task. His purpose here today, as we previously indicated, is to provide an overview of the design and build process in a large construction project. The idea of Mr. Craig testifying here is to give you, the public and the lawyers, if they need it, a primer in the issues and concepts that we'll be dealing with over the weeks and months of this inquiry. Although Mr. Craig is not being qualified as an expert today, he is an expert, and he will be dealing with, as I say, what is essentially an educational exercise for those who are watching us this inquiry and will need some assistance with some of the terms and some of the processes that will underlie much of the evidence. Mr. Craig will not respond to questions which deal with issues arising in this inquiry. He is here simply to provide background information. It will be, his evidence today will not be contentious. It's not intended to be contentious. It's intended to be helpful. So let me briefly describe Mr. Craig's professional background. He graduated from Carleton University in Engineering in 1970 with distinction. He shortly thereafter joined the J.L. Richards, a professional engineering firm with offices in several locations, including Sudbury. And he has worked there solidly since for over 40 years. For 20 of those 40 years, he practiced as a structural engineer, then chief structural engineer, and he is now essentially, for the last 20 years, been involved in project management of major projects and multidisciplinary construction projects. The exhibits we'll be referring to, just for your own edification, for the members here and for others, he will begin by giving us a slide presentation which deals with key aspects of the overview you already have and key terms and concepts. That is Exhibit 1891. That's the slide presentation. Second, he will show an interactive structural slide presentation to show you some of the key elements of the structural design. That's Exhibit 1892. He will then, in the process, show you a model of a connection, which is what is known as the construction that connects the beams to the columns. That will be Exhibit 1894. He will also show you a graphic illustration of the relative sizes of the actual relative sizes of the beams and the columns typically used in these kinds of construction. That is Exhibit 1893. And then lastly, he will describe what he understands is the Peterson roofing system that, as we all know, was used on this roof, but simply in a non-contentious way in order to describe some of the terms that are used continuously and while discussing the roofing system. So, Mr. Craig, do you care to begin, sir?
Thank you very much, Mr. Carr-Harris. Yes, today I'd like to lead you through a presentation which portrays the traditional design, bid, build arrangement for project delivery. That is as opposed to some other modifications of project delivery mannerisms, which could be construction management or fast track, design build, and other things. This particular project was done under that traditional mode of delivery. And my presentation is essentially a condensation of the information presented in Exhibit 6. Next slide now. Sorry. Yes, thank you. This is a depiction of the arrangement between the various parties on a construction project. We have at the center of everything is the owner. This is the person that wishes to construct a project and has his own financing in place to build it. He will consult with the municipality through the chief building officials and the building controls department to make sure that the zoning and the site plan control and building permit aspects of his application are in order and in compliance with the Ontario Building Code. The owner will usually, in a project of this nature, contract with an architect, an engineer, or a group of engineers to prepare construction documents consisting of drawings and specifications to describe how the building needs to be built and the various qualities and installation methods for the materials. The architect traditionally has been the prime consultant in this arrangement and responsible for the architectural design and coordination of the other engineering consultants and surveyors and planners that might be needed on a project. Architects are expected to operate in accordance with the guidelines and practices dictated by the Ontario Association of the Architects, and engineers practice under the regulations and guidelines provided by the Professional Engineers of Ontario. Once the drawings, a set of drawings or contract documents as they're referred to are completed, the owner will then take those, or the architect on his behalf will advertise for tenders from general contractors, or they will invite tenders from selected contractors that they are happy with and who have come recommended to them. After the bidding process and selection is done, the general contractor will then sign a contract with the owner to construct the project in accordance with the plans and specifications and the health and safety laws and regulations, and he will often engage subcontractors for a number of different aspects of the project, among them masonry and concrete, painting, all the various pieces that go into a project. Next slide, please. Oh, I can go back. I should mention that there is a direct contractual relationship between the owner and the contractor, and as well between the owner and the architect and the architect's engineers, but there's no contractual relationship between the architect and the contractor.
I note it says there, Mr. Craig, that there's it looks like a general review line between the architect, the engineer, and the contractors.
Yes. During the construction, the interface between the architect and engineers and the contractor is one of general review of the construction progress and the quality to make sure that it's in general conformance with the documents that they produced.
And typically, who does that general review?
Well, it would either be the designers themselves or appropriate professionals or technical specialists that they would designate to act on their behalf and act essentially as their eyes and ears.
Thank you.
Thank you.
Next.
This is a bit of a replay of these. The owner is ultimately responsible to ensure that the building is structurally sound. He will engage professionals to assist him in this. Again, the architect is a licensed professional. Design professional is responsible for the aesthetics, the building appearance, the functionality, how the spaces interrelate and people function in the building, including general code compliance, as well as occupant safety. Architects are regulated by the OAA, and they usually are retained as a prime consultant. There's no definition that requires this to be so, but it has been traditional practice, and it was very much in vogue at the time of in the 1970s and 80s. And also the architect is responsible for the coordination and design of aspects, important aspects such as the building envelope. Next, please. The engineers, the various disciplines of engineering involved in any given project, the extent and detail depends on the nature of the project. There's a structural engineer who designs the structural elements, defines the construction materials and procedures, and ensures that it meets the code. You would retain a geotechnical engineer, usually on a project, to define where rock might be or what the founding conditions might be at the proposed foundation elevation, to define bearing pressures, provide lateral soil pressure factors and importance factors relative to seismic design. Usually this involves drilling or test pits to actually physically sample the soil. They will also be usually required to do some quality assurance, quality control, which is the acronym QA/QC, testing on various elements during the construction process. You have mechanical engineers responsible for the heating, ventilating, and air conditioning systems, the fire protection, plumbing, building controls. You have electrical engineers for the power, lighting, data, fire alarm systems. Civil engineers who will design the water and sewer services to the building, design the drainage systems and the site grading and the roads and access to the local streets. And all of these professionals, if they're professional engineers, are regulated by the Professional Engineers of Ontario. Next, please. Moving to the contractor. Contractor is in this case, in the traditional sense, a general contractor who undertakes the construction in accordance with the plans, the specifications, and other contract documents that he has actually signed a physical contract with the owner to perform. He will usually subcontract a great number of components of the building process to subtrades or suppliers, and is responsible essentially to act as a coordinator or integrator of all of these trades and suppliers into a whole, complete working process, working building. And it's very much a responsibility of the contractor, the general contractor, to ensure that the work is carried out in accordance with health and safety regulations. And his subcontractors, as I mentioned, can vary. Probably 15 or 16 different subcontractors on a large project, varying from painting, drywall, masonry, concrete forming, reinforcing steel placement, structural steel supply and fabrication. Oh, I'm sorry. Get carried away.
If you would bear in mind, Mr. Craig, that not only we have live transcription, but we also have translation, and
That's
you're
true.
in an area which is very technical, and I think you would be doing both these ladies a favor by just slowing down a bit, if you could do
I will.
that, please.
Get carried away. Various subtrades, such as concrete, reinforcing steel, structural steel, supply, fabrication, erection, masonry, painting, roofing and waterproofing, electrical and mechanical, just all of the various pieces of a building that require specialty subtrades. Next, please.
The role of the municipality, again.
Yes, the municipality plays a regulatory role under the Ontario Building Code. They ensure that the local zoning requirements and the building codes are met through the site plan control and building permit application process. The Building Controls Department usually relies quite heavily on the architects and the engineers who stamp their drawings and design and take professional responsibility for them meeting the applicable code. The chief building official will review reports and certificates of general conformity which are provided by the professionals at the end of construction. And one thing to note is that chief building official qualifications may vary based on the size and the location of a municipality. It's not unusual for smaller or more remote municipalities to find it difficult to afford and attract professional engineers or architects to act in that capacity on their behalf, and hence they often don't have registered professionals on staff. In that case, they can decide on their own whether they have the appropriate qualifications and feel comfortable with reviewing and approving the drawings, or engaging other professionals to assist them. Next, please. The construction project itself begins with the choice of a site. It all comes down to location. An owner may have a piece of land that he wishes to develop a particular building on for whatever purpose, or he may have an idea for a building or a process that he wants to construct, and he will search for several sites. So it comes down to the location. The size of the site will have a bearing on what sort of building is on it, and the access to the various services and roads and transportation networks if there's a product involved or deliveries to and from it. Each site has to be analyzed to determine what its zoning is, what the required setbacks are, the amount of parking that's required, the amount of green space, and the various things that are set out usually in the municipal ordinances and zoning bylaws. Next, please. Once the site is chosen, the next phase in the construction process is the site investigation. Usually it involves a legal survey to determine property boundaries and any impediments to that, any encroachments or any other liens or anything on the property that would render it unsuitable for the proposed construction project. Then you would get into a topographical survey, which would define the various elevations and features on the site, so that the designers can appropriately provide grading, drainage, and foundation elevations suitably, and establish the floor elevations to suit the purpose of the building. Then you would move on to geotechnical studies to determine what where the founding elements will bear, whether it's on soil or on rock, and if the rock varies, what the depth to the rock is. And he would work in consultation with the structural engineer to determine the structural engineer's preferred system of foundation and the various parameters such as allowable bearing capacity or depth of piles in that type of in that instance to found the building on. And sometimes you engage in hydrogeological studies to determine what the groundwater levels are, whether there's any contaminant transport underground in the water table, or other various features that you might engage a hydrogeological consultant to do. Next, please. We come back to the triangle with the architect acting as prime consultant. In this instance, the architect would engage what we term now as building science designers. The three major disciplines are structural, mechanical, and electrical. Structural engineer for the building frame and how the loads are carried and the building is structured. Mechanical and electrical, as I described, for the HVAC, plumbing systems, and the various electrical and power and lighting systems. On the site side, the site development and the planning might involve civil engineers, civil or municipal sometimes they're referred to, geotechnical engineers, surveyors, and planners. Next, please. This is just a graphical representation of the codes. The one on the right is the Ontario Building Code from 1975. Did a little measurement. It's about 1/4 of the thickness of the 2006 code, and the pages are half the size. So it's about 1/8 of the volume of printed material as compared to that is in effect today. It's just an indication really of the increased complexity of the building process, the greater selection of materials, the greater recognition of the regulations which need to go into the building regulation process. Next, please.
I take it, Mr. Craig,
Yes.
that in relation to the previous slide, the code that we've seen was the one in existence at the time that the
Yes, it is.
Albemarle was constructed.
The one on the right is a copy of, an old copy that we have in the office of the 1975 Ontario Building Code. It was, yes, and it was in force at the time. The design process begins with what we term in the industry as the conceptual design. The architect comes up with a programming and functional layout for the building, a design concept with which he will select and recommend to the owner various materials, massing of the building, heights floor to floor, the actual dimensions of the building and the orientation of it on the site. This will be discussed in detail with the owner and preliminary budget estimates made. Usually there's one or two, maybe even more concepts that are developed at this stage. They might include a model of the building or a 3D rendering. In the older days, back in the 70s and 80s, it would probably be a hand-drawn perspective of the building from various orientation points.
So this is the first phase in the conceptual design, is that you now have the team together, the
That's
design
correct.
team there to come up with a conceptual design. And there's one shown on the right side of this page. What is that?
Those are, since we had them handy, those are some conceptual drawings and model of the Living with Lakes building that our firm did in Sudbury at Laurentian University.
It's beautiful.
Thank you. It was an award-winning project, so we're proud of it.
Then the next, you're moving on to site planning and approval.
Yes, please. The site planning and approval process involves making sure that the building, that a site plan drawing is prepared, which shows the building placement, parking, access, drainage, site services. A site plan application to the Building Controls Department is made on behalf of the owner and with the owner's full knowledge. And it's reviewed for compliance with the zoning bylaws and the standards in effect at the time. As the Building Controls Department finds differences from what they expect to see in it and their local bylaws or the building code, they'll mention these to the design team, and there will be appropriate revisions to it. And on the right, it's just a typical building site plan control checklist from a municipality that indicates the various aspects of the site plan control agreement that need to be ensured as being submitted and meeting the requirements.
So once you've arrived at the concept design, what's the next phase then? And
Next
site
phase, yeah.
approval.
We've done the conceptual design, submitted for site plan control approval, and now you move into the detailed design. The detailed design would involve the civil engineering, municipal engineering for the site plan and the services, as I mentioned before, the roads, the grading, parking, and stormwater management, which is certainly an important aspect these days. The engineers and architect would design their various systems. The architect, all the building finishes, the building envelope, materials and selection systems. The structural engineers would address the structure itself and the mechanical electrical design for the various systems that I described earlier. In the instance of the structural engineer, they have to pay attention to various prescribed load combinations for the dead load, the live load, and the related climatic conditions and geographical location,
I
which are
understand.
prescribed in the code.
Sorry to interrupt. And loads will be a subject we'll be hearing evidence about through the course of this.
Yes.
In terms of, and you have, I think, a drawing to
Yes, if we
illustrate
move to the
how you
next
arrive at.
slide. This is just a pictorial indication of some of the nature of some of the loads. You have dead loads from the walls, the floors, and the roof of the building itself. You also have permanent partitions and fixtures and services that are embedded or attached to permanently attached to the structure, and the structural engineer will estimate the amount of that weight or load on the structure. You have permanent equipment that will exert heavier loads in certain areas that have to be taken into account. At the foundation level, you will have soil and hydraulic loads, water pressure on basement walls if they're not drained or you just can't drain them effectively, and the soil itself exerts a lateral pressure on the wall. In terms of live loads, you have those such as snow, which in the Northern Ontario area we know all about. Live loads from the wind exerting lateral pressure on the walls and roof, and uplift in some cases depending on the nature of the wind. You might have loads for collected water, unintentional collected water on a roof or a swimming pool that's built in there. And you have lateral loads related to earthquake, although in Northern Ontario in general that's of a lesser concern because it's a lower seismic activity area. And then you have live loads from the people and movable furniture.
Forgive me again for
Sorry.
interrupting. By what magical route do you arrive at what the wind loads and the snow loads are? Where do you get that
The
information?
Ontario Building Code is very good. In both 1975 and 2006, there is a complete list of climatic conditions and wind pressures, earthquake, seismic factors, snow loads, ground snow loads, and then the design portion of the code, section 4, dictates to the structural engineer how he uses these loads and the factors that he works into his load combinations.
And are these loads specific to each community, or is
Yes, there's a large list of loads for particular communities, and it is interesting to note that neither edition of the code has Elliot Lake factors.
Whereas Sudbury would be there? for
Sudbury's
example?
there, Espinola's there, Sault Ste. Marie's there, Timmins there. It's I think a factor of the available data that was there and used, and a designer in that instance where his particular municipality of the building that he's designing does not have specific factors would try and triangulate and assess that location's uniqueness, perhaps, if there's anything that is known to be unusual there in terms of the climatic conditions. If not, you would actually take the surrounding municipalities and gauge which of those factors you would use. You might take a look at Sudbury snow load, Espinola snow load, Sault Ste. Marie snow load, and say, okay, I would say that Elliot Lake should have this. You make a professional judgment on it.
Thank you.
At the end of the detailed design process, there's a building permit application and a review by the Building Controls Department of the municipality. That review may be internal, or it may be assisted by a third party to be retained to help assist the Building Controls Department. Generally, that application, it's desirable to have the application done towards the end of the design process before tender, so that the results of the building permit review are known and incorporated into the contract documents before you go to tender. It's not always the case in a fast track or a rushed situation. You might take the chance that you will incorporate those changes later and negotiate any change in cost with the contractor. Generally following the building permit application, You would then go to tender or bidding to the general contractors, review those bids received, and award a contract to the selected contractor. And that's just a copy of a typical building permit notice that's posted on the site. Once the contractor has been engaged and awarded the contractor, mobilized, and started to assemble and construct the process, the construction progress requires clarification and instructions from the professionals as to the design intent. No set of documents is perfect, but it's expected that any imperfections or clarifications or unintentional, how do I put it, unintentional blunders are clarified to the builder in site instructions and clarifications through sketches if necessary, to make sure that it's clear to the builder what's required to build the building in accordance with the documents and the intent of the design. And as well, there's general site review by the professional team or agents of theirs that they've selected or approved to act on their behalf, to make sure that the general progress of construction is proceeding in accordance with the documents, and that the quality of the materials being supplied on the project is as specified. And they will also engage a testing team to do quality assurance, quality control testing.
And typically I meant to ask you this earlier, the review by the designers, does it have to be by a professional, an architect or an engineer?
It doesn't have to be. They ultimately, the designers have to ultimately take professional responsibility for whatever inspection and review is done. They could assign agents. In fact, if they were in another city far from the site, it's not uncommon in the past, especially to hire a local inspection firm or testing firm or another local consulting firm to act on their behalf and do the inspections, give them written reports, and I would expect that occasionally the original designers would visit the site. During the contract administration, as I mentioned, there is review of the quality assurance and quality control by the design team, either through an agent or personally. There would be a testing program for various materials. Concrete, sometimes sections of structural steel are tested to make sure that they have the proper yield strength. You might have an inspection of the roofing process to make sure that it's applied correctly. It's a unique science in many respects. And so the designers would set out in their specifications which materials need testing, the nature of the testing, and the codes to which the tests must comply. And there is a professional obligation to ensure that there's general compliance or conformity with the design documents, and this general review process is required by the Ontario Building Code. As you move towards the end of the construction process, you move into what we term as the commissioning phase. It's generally, excuse me, it's generally focused to a large extent on the review of the mechanical and electrical systems and their controls to make sure that they're operating correctly and will provide power, heat, light, and comfort to the occupants. Usually the commissioning process involves owner and staff training and the provision of operations and maintenance manuals to guide future maintenance of the building. And there's also particular attention paid to fire and life safety and egress systems at this time. Next slide, please.
Is the commissioning done before or after substantial completion?
It's usually done just before substantial completion. It's usually one of the elements that the designer would want to have in his pocket to make sure that the air systems are balanced properly, that all the equipment is working, because one of the tenets of substantial performance is that the building is suitable for its intended use and purpose. So it's most designers' position that unless all of the life safety and occupant comfort systems are working properly, it's not ready for its intended use.
Thank you.
At the substantial completion or substantial performance, as it's now referred to. The design team will inspect the building thoroughly to determine what deficiencies there are, how much is left to be done, and make their professional determination as to whether the building is ready to be accepted as substantially performed. If it is, there's a requirement in the Construction Lien Act to advertise this this substantial performance in the Daily Commercial News, so that any suppliers or subcontractors who might have lien rights know when they expire, and that they have to get their claims in before the expiry of that date. Following that, the Building Controls Department, or the Chief Building Official, and the Fire Department would be notified that the building is ready for occupancy in the opinion of the contractor and the professionals, and they would inspect the facility, determine whether it meets the requirements that they've laid out, and if it does, they'll issue an occupancy permit. If it doesn't, corrective measures are taken.
Thank you. On the right is a certificate of substantial completion that you mentioned, typically
right.
published.
Yes.
So Quinnen Construction was not
Oh,
any part of
absolutely
the
not. This was-
construction of the mall. This is a
It's
typical.
public record that we just pulled off of the Daily Commercial News. Just happened to be one in Elliot Lake.
Thank you.
Once, that signifies really the end of the building construction and commissioning and turnover process. The owner now takes responsibility for the building and for its ongoing maintenance and review. There's normal maintenance required on all building systems. Some are more cogent than others. The architectural and the structural systems, in my opinion, their maintenance, although it's important, is often ignored until problems occur. You don't pay attention to your roof until it leaks. You don't think about the caulking until you've got a seepage around a window. You don't think about a structural problem until something deflects or breaks or moves, or you feel some vibration and some undue stress. So it's just it's the old adage of out of sight, out of mind in many respects. There's a note here that major renovations require upgrading to current codes. If there's a significant renovation to an existing building that was designed under a previous code, that portion, or if it's extensive enough, all of the building must be upgraded to current code requirements. But the big reason that mechanical and electrical systems receive most of the maintenance and repair attention are simply because they affect users. They're obvious to the building users. If you don't have enough heat, or if you've got no power, or the toilet doesn't flush, somebody gets upset, there's a complaint, and usually the building maintenance is taken care of. Next, please. This is the final slide. It just is a typical excerpt of some of the major codes and standards and organizations that are involved in both the setting of standards and establishing regulations to which the buildings must be designed, and the various agencies that designers will refer to for the guidance.
Thank you. I understand now that you have an interactive display
Yes, I
of
do.
structural components that you'd like to show us.
I think we have to take a small break to get the board up, though.
Yes.
All right, let's do that. Is it your intention, Mr. Carr-Harris, to file Mr. Craig's CV? Was it your intention to do that?
It wasn't my plan, but
No.
if it's your wish, we will circulate it and provide it. We're certainly not hiding it. It's very.
No, I think this is not meant to be criticism, but you're rather cursory in describing Mr. Craig's experience, but I know that he has had major responsibilities with major professional organizations, and perhaps this ought to be known to everyone.
Well, then we can.
Sir?
I'm sure you have one.
Yes, I
Yes.
provided it.
Yes, we have it. Unfortunately, it's fairly modest, and in terms of what's in it.
It is.
So I have taken sort of the main threads.
The highlights.
But what we'd be happy to do is file a full CV and with all your organizations and we can file that in due course.
Certainly.
Is that possible, Mr.
No,
Craig?
no
Thank
problem.
you. I think that'd be of service to everyone.
So would you like to, we'll have a break, Your Honor, or
Okay,
Mr.
we'll
Commissioner,
take,
for...
We'll take 5 minutes. It'll give Madam Stenographer and the interpreter a minute or two to relax. Let's take 5 then.
This hearing will recess for 5 minutes. Cette audience reprendra dans 5 minutes. Order, all rise. À l'ordre, veuillez vous lever. This hearing is now resumed. Cette audience est maintenant reprise. Please be seated. Veuillez
Yes.
vous asseoir.
Mr. Commissioner, I think Mr. Craig's now set up to show the structural elements and
Thank you.
the graphic.
Am I live here? Okay. This is an interactive graphic model that we have prepared just to illustrate the various components of a typical structural steel frame construction. It's not the Algo Center Mall by any means, but I will just go through and show you some of the various terminology and members that we use in the structural engineering profession. This is, in its entirety, a structural steel frame. These are reinforced concrete piers with spread footings.
I just interrupt you for a moment. I'm sorry,
Sorry.
Mr. Craig. I'm not seeing the transcript being produced on my screen. I don't know if it's the same for everybody else. Have a look now. Is everybody else getting the transcript live?
No,
Or not
just,
getting
just
it?
yourself. Here.
It is coming through, yeah.
Okay, let me try again, sorry.
No.
Still with it.
If everybody else is getting it, that's fine. It's not the end of the world for me, but I thought it might be a general problem. Go ahead then, please. Sorry, Mr. Craig.
No problem. We have many components in a structural system. The horizontal load-carrying members are called beams. The vertical load-carrying members are called columns. The area where they connect to one another is a connection. Some of the horizontal load-carrying members, the secondary members, can be open web steel joists, which are lighter, more slender members, similar to the wood joists in a floor, which span between major walls or beams. And they consist of a top and bottom chord, C-H-O-R-D, interconnected by a steel rod sloped series of web members. Secondary load-carrying members can also be lighter steel beams and spanning to other beams, or in this case, directly to a column. This beam is what we call a cantilevered beam. It extends across its support at the column and cantilevers out, so it doesn't need any other exterior support because it's stabilized by the weight and the connection of the beam in the main span. This is a depiction of hollow core pre-stressed concrete slabs. See if I can rotate it a bit, but you can see the ends of the slabs are actually, they come in 4-foot sections, and they're any given length, and the depth of them in some instances goes 8, 10, or 12 inches in depth, and sometimes even more.
And the significance of those is there's no dispute. They were used, slabs were used.
These slabs were used at the Algo Center Mall, and they constituted the platform upon which, the platform which sat on the structural steel frame at the roof parking level. Those are manufactured in a pre-stressed concrete manufacturing plant and prepared and delivered to the site and erected. Sometimes joists will support a thin concrete slab that's placed on a form or a V-pan, we call it, and a 2.5 or 3 inch or more topping of concrete with some welded wire fabric, which is light reinforcing in a square pattern installed in the slab. These diagonal members are typical cross bracing to prevent the frame from swaying under lateral load, wind, or earthquake. This is an infill wall you'll hear referred to. And those, I guess, are the various significant elements of a steel frame.
Now, I think you have a mock-up of an example
do.
of a connection. I wonder if we start off by saying it's not to scale. but
No,
it's
it
for
isn't.
illustrative purposes only.
We couldn't have lifted anything of this nature that if it was done in structural steel. So we used fiber reinforced plastic members, and they aren't to the scale that we've referred to in this project. This is a column, again, a vertical member supporting a load. This is the column web, the central part, and it has two flanges, column flanges. This is a beam that's connected to the column through two clip angles, and the beam has a web again, and a top. This is the beam top flange, the beam bottom flange, just by virtue of its orientation. It's very common that columns are prepared, well, all of the members are fabricated in a shop to a set of shop drawings that are based on the design drawings that the structural engineer prepares. And the connection design, in this case, consists of a pair of clip angles that are, in the case of the Algo Center Mall, were welded in certain instances, welded to the face of the column flange. These are out of scale, of course. They would terminate here and have a weld running the length of them and up and across the top. And the pair of angles would be on the column when it's erected on the site. Then this beam would be brought in, dropped in place between the angles, and bolted in place with high-strength bolts.
And that's what transfers the load on the beam to the column.
That's correct.
That connection.
Any loads that happen on this span, such as this, the load from the slabs or the joists is carried by the beam to the column and transferred into the column through this connection. And that's the connection.
Can you read that exhibit number for me? I don't
Oh,
think
yes.
Is it,
01894.
thank you, exhibit 1894. Now, you mentioned in your description that these are not to actual size, but I understand you have a graphic illustration of their relative sizes versus the beam and the
Typical
column.
beams in the floor or in the roof framing of the Algo Center Mall were wide flange, 24-inch deep, wide flange. This is to scale. It's 24 inches deep, and it's 12 inches wide, or the width of the flange is 12 inches. This is the size, the actual size of the column that it was connected to. It's called a W10 by 49. It's 10 inches deep, just under 10 inches deep, and 10 inches wide across the flange. It's virtually a square section. These are all hot rolled structural sections that are produced in a structural steel mill.
So that gives you the sense, Mr.
The
Commissioner,
actual
the
size.
actual size of these.
This
And why we didn't carry them in here today.
this column here would have been 10 inches this way and 10 inches that way, and this beam would have been 24 inches, so it would have been this high if it was sitting on the desk.
Okay.
Was that made an exhibit?
I believe
Sorry,
it's
Howard.
exhibit 1893.
Thank you.
Now, could we bring up exhibit 14? What we're looking at there is the roofing system, so-called Peterson roofing system, which is alleged to have been installed on the roof of the building. I don't think there's much doubt about that at this point, but to avoid any contentious points, all we'd like you to do, Mr. Craig, is simply translate for the public and for the lawyers what the roof system consisted of. This is what was, we understand there, and when the building was built in 1979-80.
This is a sketch from the Peterson proposal to the owner, indicating what is believed to have been the system as it was installed. It consists in the middle of the 8-inch hollow core, pre-stressed hollow core slabs. On the underside, it's 3-inch thick thermofiber insulation with a foil facing.
So the wavy line at the bottom
This is insulation here, across here. That's the indication. And it looks like they're indicating mechanical attachment of the insulation to the underside of these concrete slabs. These are the grouted joints at longitudinal joints between adjacent 4-foot wide panels. And this is a concrete, it's indicated as a 3-inch durable concrete composite wearing slab, which is concrete placed on top of the hollow core slabs and intended to be bonded to them. And the dotted line with the X's indicates what's again termed as welded wire fabric, which is a light drawn steel square grid of reinforcing that is
would be
placed
poured concrete?
This is placed on site, yes. The slabs would have been in place, prepared as needed to ensure that you got the bond of the concrete topping to them, and then this concrete would have been placed, and it was a variable thickness according to what I've been advised, to provide some drainage at the top surface. This is indicated as a barrier penetrating concrete sealant. This is it's a isoflex sealant in the crack control system. These were intended to be tooled joints in the concrete just before it hardens to try and encourage cracking in a controlled pattern along these joints, and then filled with a sealant later. And as I mentioned, the barrier sealant was to be put on top of it. And this is simply a section at an expansion joint with another isoflex pre-molded expansion joint seal in here. And these expansion joints are generally designed or intended to allow for building expansion and contraction and controlled in a controlled nature, so that it doesn't induce needless stress on the building.
Okay, and I understand that there's some evidence that the strip that's described as item 1 there may have been a plug later on by some kind of change. But other than that,
It's possible, but we have no evidence
okay.
that we've seen.
You mentioned bonding between the core slab and the upper layer.
Yes.
How's that bonding achieved, sir?
There are various ways to do it. I don't know what this specification was, Mr. Commissioner. Sometimes you would brush the slab, clean the base slab well. If it was properly roughened, we would dampen it to make sure that it didn't suck the water out of the fresh concrete too quickly and impair the bond. And you can use a mortar slurry, paste, to brush into the slab to help bond the new concrete to it. Or there are various chemical products such as latex additives or epoxy bonding agents. I don't know what was intended or what was used here, but there's a definite process to make sure that you get a proper bond to the fresh concrete to this hardened pre-placed concrete.
And the lower third, which is
The insulation.
insulation material, that's added on after?
Yes.
Is it
yes.
sprayed on, or is it?
No, this apparently is a rigid foil-faced insulation board, 3 inches thick, that would be like, it would appear to be rigid fiberglass or something like that. I honestly don't know what this thermofiber is, but it sounds like a fiber product that has a glossy foil facing, probably intended to act both as a vapor barrier and a heat rejection to help its heat properties. And that would be actually cut and fit to the underside and attached.
After the core slab's been installed?
That's correct. And usually well down in the process, once the building is completely waterproofed and sealed, because you don't want unintentional leakage getting through and damaging the insulation.
Thank you.
Thank you, Mr. Craig. Subject to your wishes, Mr. Commissioner, those are my questions, and there may be some questions from the floor.
All right. Anybody have any questions of Mr. Craig? Would you like me to take a short break as you consider whether or not or how to formulate your questions? Mr. Longo, you're indicating yes?
I'd like to, yes.
All right, well, let's let's unusually take our morning break at this point, and then we'll hear from you after that.
Order all rise. À l'ordre, veuillez vous lever. This hearing will recess for 20 minutes. L'audience reprendra dans 20 minutes. Order, all rise. À l'ordre, veuillez vous lever. This hearing is now resumed. Cette audience est maintenant reprise. Please be seated. Veuillez vous asseoir.
I understand there are a number of questions, Mr. Commissioner.
All right, thank you.
Good morning, Mr. Craig. My name is Joe Bichelli. I'm Mr. Saunders' lawyer. Thank you very much for your help this morning. Just want to clear up one matter that you touched upon. It's my appreciation from your evidence that as general protocol within an engineering firm or a project, there are technicians or individuals who obtain information or raw data and provide that either to the architect or the engineer for his or her opinion. Is that fair?
That's correct.
And that applies not only with respect to new construction, but also doing inspections of existing buildings. An engineer may have staff members or technicians attend there, take the raw data or information, provide that information, and then the engineer exercises his or her opinion with respect to that information. Is that fair?
That's fair.
And that provision is provided for in the regulation 260/08 of the Professional Engineers Act, and the document number I'm referring you to is OR_E 00000000. That's 8 zeros, 4. If we could have that brought up, please. The attachment is part of that overview report, the actual regulation. It's page 62, if I can understand my printout correctly. The last numbers are .62. Yes, thank you. Section 1 indicates the duties and responsibilities, and then subsection 2 of that regulation states that the professional engineer may delegate one or more of the functions or requirements described in paragraph to another person if it is consistent with prudent engineering practice to do so, and so forth. Is that fair?
I don't see that on the screen. I just want to,
Oh,
sorry.
just,
Okay, there we go.
there you go.
Please. Okay. And does the sentence finishes on the next page?
Yes.
I would agree with that.
Thank you very much, sir.
Thank you.
Those are my questions.
Thank you.
I wonder if I might go next, Mr. Professional? Good morning. My name's Rob McCrae, and I'm solicitor on behalf, or representative on behalf of Mr. Bob Wood. As Mr. Bishagula indicated, thank you very much for the information that you provided. I have a couple of questions with respect to the information. Now, Mr. Commissioner, I understand that from speaking with Mr. Carr-Harris that there may be a number of technical questions that this wouldn't necessarily be the time to ask those questions today. And just for the purpose of a clear understanding, Mr. Carr-Harris has indicated that if the questions are not fully answered by the professionals or the witnesses that attend, that we would be in a position to recall the witness, and we could put those questions to him by way possibly in advance of written interrogatories so that those questions could be answered.
I think that's what Mr. Doody indicated yesterday, that for our purposes today, Mr. Craig's evidence is restricted to generalities, if I can use that expression, rather than specifics. But if that is of concern, certainly you can reapply to me, and I would most likely be favorably disposed to allow the recall of the witness.
Thank you very much,
All right.
Mr. Commissioner.
Yep.
When we talk about, you had given evidence with respect to a roofing structure, the Peterson roofing structure, and I wonder if we could bring that slide up, if we might, Mr. Kuka. The Peterson, yes. Thank you.
Is that the one, Mr. McCrae?
Yes.
Yeah.
I'm sorry, I thought it would be appearing there. Are you able to see it, Mr. Craig?
Yes, yeah, actually, I've got my cheaters on now.
Okay, great. You talked about the insulation being, that's in detail number 3, and it's reflected on the bottom of each of those cross sections being, as the insulation being installed below the precast concrete.
That's what this section indicates, yes.
Right, okay. Is that a common, within the building industry, is that a common procedure to install the insulation on the underside of precast?
It would be up to the professional who designed the system to consider the various influences and the conditions to which he is prepared to make sure that the system works overall. It's a matter of building science.
And as part of that building science, then, would it be a calculation to determine thermal expansion and how that would be impacted?
Forgive me, Mr. McRae, for interrupting. Mr. Commissioner, I think my friend is getting into areas that may be contentious in the ultimate evidence. And I just want to make it clear that, to all, that the witness, as you have said, is not here to deal with contentious issues, but just simply as a backgrounder. He's described what the roofing system is consisted of, which is our purpose today, to tell him, and not have a discussion with others about what is an appropriate element and what isn't.
Might I respond, Mr.
Yes,
Commissioner? Mr. Carr-Harris is referring to this as a roofing system, and in my submission, that's to be determined at some point in time. I didn't understand it to be contentious with respect to thermal expansion, whether the insulation, whether this witness was able to indicate that if it's insulated from the inside, whether that would have an impact on the thermal expansion of the precast concrete that would be then exposed to the elements and not subject to the protection of the insulation.
My view at this point is that this is sufficiently general, Mr. Carr-Harris, that the question can be allowed and that can be explored if the witness can answer.
I can give you a general answer
Certainly.
in principles. If the insulation is applied to the inside of the structure is then subjected to greater thermal expansion and contraction. If the insulation is applied above or outside the structure, then the structure is protected and has a less likelihood of large thermal expansion and contraction under climatic conditions.
Thank you very much. Then with respect to, with core slab, and you spoke about core slab and the bonding of a concrete, if we could call it a screed or a topping on top of core slabs. Am I correct that generally there's two designs of core slabs? One being a smooth finish that's intended to accept carpet or something of that nature, and the other a raked finish that's designed specifically to receive a topping?
That's correct.
Okay, and the raked finish, is that supplied at the company, at the factory?
I believe it is, yes.
Right. And would you be, are you able to provide any evidence today with respect to the ability of a contractor to utilize a smooth surface precast in order to, the top side, in order to properly bond a topping mixture to that?
It's more difficult to get a complete and thorough mechanical bond to a smooth surface than to a rough surface. If the slab is smooth, it requires more preparation to obtain a suitable bond.
Fair enough. And that, as I understand it, that's why from the factory, a precast that's intended to have a topping bond to it actually has a very coarse raked finish?
Usually.
Okay, thank you. Then, with respect to core slabs and the installation of core slabs, are you aware of any requirement or a design issue with respect to where the core slabs join together, the use of reinforcing bars in order to create a certain redundancy?
The best reference to that would be the manufacturer's recommended installation details. And that's what you would refer to see what they recommend for their system in place and its complete installation methodology. And that's what you would normally specify to be done. I can't state for sure, because I don't have the core slab literature with me, whether they were recommending installation of steel or whatever. So without that to refer to, I'd be speculating.
We'll have someone from Core Slab, Mr. Carhauer, is that correct?
That's correct.
That question would probably be better put to the individuals who make the material.
Certainly, Mr. Commissioner, thank you. Then my last question deals with how you would properly, as an engineer, how you would properly describe the structure that the Algo Mall was, in that in some of the documents it's referred to as a parking structure. Some documents refer to it as an overhead parking structure. Is there a formal engineering designation with respect to the distinction between a parking structure and, say, a ceiling over a mercantile area?
I think this is an adaptation of building forms. You have a parking deck over top of an occupied space. So the deck itself has to now serve two functions. It has to serve the function for carrying the load of the vehicles and the conditions to which that is are going to impose on the structure. And it also has to function as a roof over the occupied spaces to keep the elements out.
Thank you. Then with respect to that, how is that distinction actually carried out as part of the planning process? Does it then have to conform, or would it then have to conform to two different sections of a building code?
You would have to look at all of the conditions that it was subject to, and I think as a prudent designer, take into account the worst of either condition. You say, what are the conditions imposed in its function as a parking deck, and what do I have to ensure is done to make sure that it can function effectively that way, carry the loads, etc. And what, as a building enclosure, what do I have to put in place in my design to ensure that it functions effectively that way?
Okay. And then one final question. When you talked about there being a requirement to essentially deal with designs or issues that may arise as a result of the construction, could you provide me an example of how that information would normally flow with respect to, let's say that, by way of example, there's an issue with a foundation. There's an issue with being able to fit the foundation into an area, and that's just hypothetical. But how does that information flow back to the person in a normal construction process who would then be able to make a final decision with respect to modifying that?
Well, if you're indicating that the question's related to a contractor discovering that he can't do what is shown on the drawings, I can't physically accommodate this, what you've shown in the space you've shown or whatever. He would then contact the traditional process would be a request for information. We're more formally referring to them as RFIs today, requests for information. And he would communicate, depending on the urgency, would dictate the type of communication, communicate with the architect or engineer, whoever's in charge of the project, his question, and say, this is the problem, this is what the drawings show or what they don't show, how should I proceed? I need some information to allow me to construct this. The professional would then, in whatever discipline this affects, would review the request for information and as promptly as possible, consider all the factors, give a clarification or an instruction if it meant changing from what was shown on the drawings.
When you say a clarification or instructions, would that be done formally normally?
Usually, it should be done in writing if you want to ensure that everybody understands everything, and all of the appropriate parties should be included in that correspondence. And if the instruction or clarification in the contractor's opinion affects his timing of progress or the cost or difficulty, he would then most likely submit a change order or a request for additional compensation in whatever form he termed it, and or an extension. And then there would be another judgment, usually in consultation with the owner, with the architect or engineer, the consulting team, to see whether this would be accepted and how it would be paid for.
All right, and then say that modification required a change or a modification to a drawing, a structural drawing or an architectural drawing. How does that change get incorporated into the drawing?
Well, usually, if there's to be a change to a document prepared by a professional, they should prepare a sketch or a written notification as to what the change is, how it affects the contract documents that they prepared, and it should be in writing and communicated to everybody.
When you say how it affects, how does someone determine, an example where there's the contractor comes back to the general contractor and says, I just can't do that, and I need a change, and that change is accepted. Who would be responsible for ensuring that all of the design, or the individuals who are involved in the design of a building would be notified of that change so they could determine whether it impacted their design?
Well, at the beginning of a job, you should set up lines of communication between the contractor and the design team, the design and contract administration team, to determine how this information would be transferred, whether there's a single person point to point, whether the project manager for the architect or whoever is the prime consultant is the single distributor and receiver and distributor of information, and both ways, taking it in, getting an answer and getting it back, or some other process that was put in place at the beginning of a job.
And that would be designed to ensure that all the parties that needed to be made aware of that would in fact be made aware of that.
That's the intent of
That's
doing
the
it
purpose
that
of
way.
it. Okay, thank you very much. Thank you very much, Mr. Commissioner.
Great.
Good morning, sir. I introduced myself
Morning, yeah.
before the session. I'm Leo Longo, and I represent the Ontario building officials. There were three areas I wanted to briefly address with you. The first dealt with prime consultant. In your own words, how would you describe the role, the responsibilities, and the obligations of a prime consultant?
Well, very briefly, the prime consultant is the owner's prime contact for his design and contract administration process. It's the entity who will lead that process on his behalf and subcontract with others or coordinate with others. If the owner has specific preferences and decides to contract directly with other subconsultants, he should still choose one of his consultants, and it's usually the architect, to be the prime consultant who is responsible for his discipline and coordination of the other disciplines to provide a complete coordinated package.
Is the name indicative of the significance of the role, prime consultant?
I don't know what you're getting at, to tell you the truth. It's the primary consultant, if you wish to call it that, the lead consultant. That's how I would determine it. So in a pecking order, they would be the leader, and the rest of the disciplines supporting the process would be the followers, working cooperatively to produce a coordinated set of documents.
Now, in your overview statement and in your presentation this morning, you indicated that architects are usually the prime consultant or can be the prime consultant. Is that correct?
That's correct.
With your permission, Mr. Commissioner, I just have an extract of the Architects Act, just so that the record would indicate that the Architects Act actually makes provision for an architect being a prime consultant. That's Section 11, Sub 4, Paragraph 8 of the Architects Act. Are you familiar with that or understand that's the...
I understand what it's saying.
Thank you. And just so that the record is clear, if I could remove that and place this on the screen, you'll see that prime consultant is also addressed a little lower, Ms. Kuka. Just if you can bring it down. No, the other way. Thank you. So the Professional Engineers Act, Section 12, Sub 6, Paragraph 8, has a mirror image of the same clause, that an engineer as well as an architect can be a prime consultant.
That is correct.
Sir, I've checked both acts, and apart from this reference that I've just taken you to, I see nothing in either the Engineers Act or the Architects Act that actually describes what the role and the responsibilities are of a prime consultant. Do you agree with that?
I'm not sure if it's in the Act themselves, because I haven't reviewed the Act for those
Okay.
wordings.
All right. I do, if you notice on the screen that's in front of you, give an extract of Exhibit 6.1, which is your professional engineer's guideline dealing with structural engineering services, and it gives a definition of prime consultant. Is that, in your view, an accurate description of a prime consultant?
I believe that's the role that I was describing to you, yes?
Thank you. And if I could go back to the first sheet. I take it, sir, in your experience, you've had to deal with the Building Code and the Building Code Act.
Yes, I have.
All right. Would you agree with me that the term prime consultant is not found in either the Building Code Act or the Building Code itself?
Without doing a complete search of the Act, I wouldn't want to make that statement.
All right. Would it be fair to say, in your experience, if one were to try to find what the role and responsibility of a prime consultant, if they looked in the Building Code Act and the Building Code, they'd come up short, or that might not be the
I would guess
search?
that to be the case, yes.
All right. And thank you. So I appreciate that. In your view, I know you haven't been qualified as an expert yet, but Mr. Carter said you're highly qualified, so I'll ask, would you agree that those very two thick volumes of the Building Code 2006 that you have on the bookshelf there, that amongst its terms, it might be useful if somewhere in the code a description was given of a prime consultant and perhaps described the duties and obligations and role of such a person, if that definition isn't there now?
I think it would be useful, yes, in my
Thank you.
opinion.
The second area I'd like to turn to is maintenance of buildings. And if I could ask Ms. Kuka to turn up Exhibit 6,
Shall we
paragraph
make those
68
two
of the...
documents that you provided, Mr. Longo,
Oh,
exhibits,
Would you like to mark?
we might as well mark them, and for
Okay.
completeness, what numbers should we assign to them, Ms. Cooper?
1896 and 1896, 08, 1896, and 01897.
Thank you, go ahead.
Thank you. If I could then ask that Exhibit 6, paragraph 68 of the overview.
Paragraph 68.
Paragraph 68, please. Mr. Craig, in there you indicate that the Building Code Act and the Building Code, once a building like a shopping mall has been completed and an occupancy permit issued, ongoing inspections by the municipality of the structural elements of the building are not required, and that it's up to, inspections normally occur on specific complaints. Is that correct?
That's our opinion as to the process that.
And just to
that occurs.
confirm, it's the Ontario Building Code, it's not the Ontario Maintenance Code, is it?
That's correct.
All right. And, sir, I have an extract from the Building Code Act, which isn't part of Exhibit 6. You're familiar with Section 34, Sub 1 of the Building Code is the regulation power for the building code itself, and explains all the things that can be in a code. What I'm showing on the screen is Section 34, Sub 2 of the Building Code, which was only introduced in 1992 with the new Building Code. And that section says the Lieutenant Governor and Council may make regulations to establish standards that existing buildings must meet, even though no construction is proposed, including regulations, sub B, establishing standards for maintenance, occupancy, and repair. And, sir, you'll see in subclause 3 that it says a regulation made under this act can apply to buildings whether erected before or after the coming into force of this act. And then you see the purpose of the regulation under subsection 5. Sir, to my knowledge, the province has never exercised its power and actually made a regulation under subsection 34.2 dealing with the maintenance of buildings. Is that your understanding as well?
That would be my understanding.
All right.
I could not state for certain because I'm not aware, but that would be my understanding, yes.
All right. And, sir, in your practice over the years, have you ever mused as to whether it would be useful if there was a building maintenance standard that had been issued by the province?
Well, generally, we've experienced the situation where the municipality itself has enacted property standards which deal with the maintenance and safety of buildings and maintaining the condition of the buildings. So we really don't postulate as to whether the province should get into that process or not. So I can't give you a definitive answer on that.
With respect to this issue of property standards that you've mentioned in municipal bylaws, you'll agree with me, sir, those are discretionary and not required of a municipality to enact?
That's correct. That's correct.
Thank you. And, sir, Mr. Commissioner, is it your wish that that should be marked? Next one. Thank you.
01898.
And the final area I wanted to explore with you was just site plan control, and just two very brief questions arising from that. I started practicing in the late 70s, and my recollection was that's about the time that site plan control was first introduced in the Planning Act. Sir, is it your understanding, or will you confirm for me, that it's fair to say that site plan control was a discretionary power that municipalities had as an extra layer of approval, but it was not a required power that they must exercise?
That's my understanding, Mr. Longo, but I couldn't confirm that for sure. We have planners on staff who make sure that we understand it afterward.
Sure. And secondly, I take it in providing your overview, you weren't in any way suggesting that Elliot Lake had site plan control at the time of this, the construction of this
was a
mall?
general description of the process as it exists primarily today.
Thank you very much, Mr. Craig. Thank you, sir.
Thank you.
Good morning, Mr. Commissioner. Mr. Craig, I introduced myself to you on the break. My name's Louisa Ratek. I'm counsel for PEO. If I could have Exhibit 0189 brought up. Should be Mr. Craig's PowerPoint. Yes, if we could have I think it's the third page in. So the title page, the first page, the second. Yes, thank you. Have that up on your screen, Mr. Craig?
Yes, it is.
Great. So I have just one question for you, sir, or perhaps two. In the last bullet point, you describe, as sort of in the usual course, the architect being retained as the prime consultant. Mr. Longo talked to you about that a few moments ago. And you said that the architect as prime consultant usually has is responsible for overall design and coordination, including the building envelope. Can you describe what you mean by the building envelope, sir?
Building envelope are the walls and roof of a building which separate the interior from the exterior. That's the envelope which encloses the building.
Great. And in your experience, would waterproofing be included in the building envelope over which the architect would be responsible?
In our experience, yes.
Thank you, sir. Thank you, Mr. Commissioner.
Thank you. Sir.
Mr. Commissioner, it's...
Just hold on for a second.
Certainly.
Je te comprends. Yes, go ahead, please, Mr. Kearns.
Good morning, Mr. Craig. My name's Doug Kearns. I'm the lawyer for one of the owners of the building in the course of its history. I have a couple of questions for you. The first is, in your overview, you indicate that one of the options that's available to the chief building official when they're presented with plans is to ask the PEO to review them. Was that option available in 1978, to your knowledge?
I don't know that I actually said that, to tell you the truth.
Oh,
I think the chief building official has the option of retaining other assistants, but I don't know that I said that.
Not asking, I didn't recall him saying that, referring specifically to PEO.
PEO. In reviewing plans and specifications for a building permit?
yes.
I don't believe I said that.
Okay, then let's just have a look then. You, I think, prepared the overview report talking about designing and building a large construction project? Or is that you? Did you?
Yes, I and my staff, yes.
Oh, okay. And on page 10 of that, I don't know how best to,
What page is that?
page 10 of the overview report, which is,
Oh,
Bring that up.
overview report?
yes, and paragraph 43. This is under the section for building permits. And
They have the discretion if they wish to do that, yes.
Yes, I'm
Oh,
sorry,
okay,
that's-
I didn't say that in my presentation. I thought that's what you were saying.
Oh, no, I meant in your
I didn't allude
report.
to that in my presentation.
Okay.
It's
My
it's
question-
not, in our experience, a likely thing for them to do, unless they have a question as to the professionalism of the design that was presented to them.
Okay, and that really was my question. I mean, is that something that's done from time to time in your experience, or is that an option that's there that is almost never used?
I believe it's occasionally used, and I think only the PEO could comment on the frequency with which it happens, but it's an option that the CBO does have.
Okay. The next question I had to do with a statement that you made, which was, no set of plans is perfect.
That's correct.
Okay. Tell me, what are the reasons for that? What imperfections ought we expect to find in a set of plans?
Well, that's a broad question. You can have, people are human. Humans make errors. Professionals still make errors. It's about keeping the errors to a small and manageable amount and making sure that they're not serious errors. That's what a professional's job is. So you might have a discrepancy between one drawing and on the architectural drawings and a dimension that's given there, and a discrepancy between the similar dimension on a structural set of drawings or something, so that there's a clarification required. And where if the contractor just built it according to the one set of drawings, the architectural drawings, he would maybe miss something that the structural engineer should have known about. So there's coordination that can be overlooked or missed or a mistake made. Those are the types of errors that are common. It's usually related to dimensions or some other misunderstanding of a detail or something shown inappropriately that requires correlation and was missed.
So these plans could often be living documents. They need to be changed and amended and varied from time to time.
That's correct, but if they're properly prepared in the first place, they are a complete, coherent set, which require minor clarifications and tweaking.
Okay, thank you. The next question has to do with bonding. Mr. McCray asked you a bit about bonding, and the Commissioner as well asked you about bonding. What's the purpose of bonding the concrete topping to the precast slabs?
Well, core slab or the manufacturer of these precast slabs would be the ones that were recommending that it be a bonded topping. That's what they wish to have as part of their performance.
But as an engineer, is there
Well,
some-
there are times when you are looking for what we term composite action between the topping and the main body of the concrete to help to give it additional design strength, where you really rely on that bond. But that I do not believe is the case in this instance. So it was a desire to have a tight, uninterrupted adhesion between the new concrete and the existing and the concrete core slabs.
Okay, and as an engineer, you're not 100% certain on why that would be wanted in these circumstances?
I think it's a preference of the, you can design an unbonded topping that still functions correctly, and you have to take into account the different factors that would be involved, because it's now not expected to be bonded to the top of the slab. So you would have to increase the structural capacity of the slab because it might be thicker, but it's not innately required unless the designer of the system, core slab in this instance, said that any topping should be bonded.
Okay, and the last thing is just, if I could have Ms. Kuka pull up Exhibit 14. Do you have that,
Yes,
Mr.
I
Craig? It's just not clear to me in this picture. I see the top layer is the topping, the middle layer is the concrete slab, the bottom wavy layer is the insulation, is that
That's
correct?
correct.
Where's the beam that would be?
It's not shown.
Is it going to be, whereabouts should it be?
Well, it would be somewhere either in the distance beyond where this section is cut or this side of it. You don't see the beam. The top of the beam, or the top of the slab, of the flange, if you see the top of that, would be behind this. It would interrupt the insulation, of course, because the beam would be spanning this way, and these slabs, you'll see the cores in the slabs are indicating that the slabs are spanning perpendicular to the page. So that model that I showed indicated that the slabs are supported on one end by a beam and on another end by a beam. And this is a section cut through that slab system in between that location.
Thank you very much. That explains it exactly. Okay, thank you. Those are my questions.
Mr. Kearns?
Good morning, Mr. Commissioner, Mr. Craig.
Ms. Carr?
My name is Alexandra Carr. I represent two community groups, Elmac and Sage, in this inquiry. And I just have one question, if Ms. Kuka, you don't mind pulling up Exhibit 14 again that we were just on. Mr. Craig, would you be able to describe, we were talking earlier about the Peterson waterproofing system, and I'm wondering if you can describe the difference between this system and a conventional waterproofing system? If there is such a thing as a conventional
Yeah,
waterproofing
that's
system.
this system, by its design, relies on the integrity of the topping and the joint system and the waterproofing sealer on the surface to prevent water ingress through it into the slabs and hence into the structure. A conventional system would incorporate a waterproofing membrane somewhere in this assembly, either on top of the, directly on top of the structural slab, and then you would build up from there with protection layers or drainage layers and a surfacing, and that waterproofing membrane would serve the function of protecting against water ingress into the structure and into the inside of the
Okay.
occupancy.
Thank you.
You're welcome.
You've used the expression Peterson system. There are other systems, obviously. Can you give us a couple of examples?
As far as I know, this was a relatively unique system that came into, that was being promoted at the time, around this time, and previous for toppings on parking garages. And I believe that this system was proposed for this situation, which enclosed an occupied structure, and probably was getting to its limits, or testing its ability in a more serious situation, because now you have any leakage that's unintended gets right through it. But it was, I do not know of other systems that were intended to rely on the concrete topping and a jointing system with sealant in the joints and a sealer on the surface to act as the waterproofing system over an occupied area. I don't know of any others.
What would you see today?
What I just described, I would expect that you would have a sound sloped structural system that was clearly sloped to drains, a waterproofing membrane with appropriate flashings for any penetrations and curbs, etc. Something to protect the waterproofing membrane from physical damage during construction, and then drainage and insulation and a wear course that again was sloped to the drains. And you would expect drains that drained at the surface and at the membrane level to ensure that water that on the surface, the bulk of the water would be deflected to drains and run off, and any water that actually got through the wear course or topping system would get into a drainage layer and then be able to find its way into a drainage system and protect against unintentional penetration.
And is there a name to that?
No, there are numerous compounds that could be used for the waterproofing membrane. In fact, in a pure garage where you don't require insulation, often you've got what they are now calling traffic bearing systems, which are layers of urethane coating or other elastomeric material with a a wearing surface on the top of them that are applied directly to the sloped concrete structure, and it simply protects it against penetration of chlorides and water through to the cars and other areas of the garage. If that's in over top of a lived-in area, it becomes more problematic because now you don't have insulation. So you have to then go to something like I described, where a system is built up.
Right. I suppose the only reason for my question is you're describing a Peterson system. Is there a Belanger system?
No,
Is there
not that
another,
I'm aware of.
that
Mr.
has a
Commissioner,
name
no.
that's
No,
in common use? Yeah.
no, this
Okay.
was the only one that I've come across in my experience. Let's put it that way.
All right, thank you. Anyone else have questions of Mr. Craig? Mr. Carr-Harrison in reply, or reply, any?
I have no
Not
follow-up
replied?
questions.
No further follow-up questions. Thank you very much, Mr. Craig.
Thank you, Mr.
We may see you later on.
Thank you.
Mr. Carr-Harris?
Mr. Commissioner, Mr. Craig is our last witness of the day.
Okay. We'll rise till 9:30 tomorrow morning.
À l'ordre, veuillez vous lever. This inquiry is now adjourned until 9:30 tomorrow morning, March the 6th. Cette audience est ajournée jusqu'à 9h30 demain matin, le 6 mars.